Okay, I'll get going again. Just to review what we're going to talk about this afternoon. We'll start off doing a little bit about LNG technology. So look at the different ways LNG is made, through to things like floating LNG systems, a range of other technology issues. Then we'll talk about shipping, which is absolutely critical to the LNG industry. Then move on to the contracting process. How do you actually buy LNG? What are the issues? We'll then have a coffee break. Then it's quite a long session on LNG pricing. And finally, we'll talk briefly about scheduling. So to start off with LNG technology, and I won't go into a huge amount of chemical engineering detail here, but if the process is essentially the same as in a domestic refrigerator. It's a refrigerant is evaporated, and that causes a reduction in temperature in the heat exchanger. And if you do that enough times with enough different types of refrigerant, you will be able to reduce the temperature down to minus 162 degrees centigrade, at which point the methane-ethane mix, it's predominantly methane, will liquefy, and you run it off down into cryogenic storage tanks. There are a few issues with this. Firstly, it's quite power intensive, because you need to keep compressing refrigerant and then evaporating it, compressing it, evaporating it. And a lot of the work that has gone into liquefaction technology over the years has been around making this absolutely as efficient as possible to get the amount of power that's required to run it reduced as far as is possible. The other thing you must do before you do this is remove all the impurities, because if you have anything in there that will solidify when it freezes, when the temperature is low enough, it'll block everything up. So you've got to take out things like carbon dioxide, heavier hydrocarbons like propane, butane, and those sorts of things. There are a number of different technologies, but I'll just talk about a couple of the main ones. I'd probably say the main one is called something by a company called Air Products. It's a US-based company. C3MR is one of their technologies. C3 is propane, and MR is mixed refrigerant. So it's propane plus mixed refrigerant. So it uses different types of hydrocarbon to as the refrigerant. And it's got this very, very large heat exchanger. That's a picture of one on the right-hand side on its side. And in fact, at one point, the size of LNG trains was limited by the size of heat exchanger they could get out of their plant in Pennsylvania on the rail cars that they had to take it out on. They seem to have got around that somehow, but they can go up to very, very large sizes, 6.5 million tons a year, even bigger than that. But you'll often see these in, I've got some pictures of it in LNG plants later. This is probably the main technology, one of anyway. The second one is this, which is called ConocoPhillips Optimized Cascade. ConocoPhillips is the licensor for this. So this is a sort of, I think it's less technically efficient, but cheaper to build. And it uses a different sort of system involving things called cold boxes, where you put all the equipment in literally a cold box to try and reduce the amount of heat that is lost. It's usually built by a company called Bechtel, who anyone who's in construction would know them. And there are lots of examples. Wheatstone is a project I worked on in Australia. So we built one project called Gorgon with the first technology, and then one pretty much right next to it using this technology, which is interesting. So why didn't you use the same technology so you could, similar spares and training for the operators and all that sort of stuff. But the point about these technologies is that it's generally less about which technology you want and more about finding somebody who can actually build it when you want it built. So, contracting for these projects is really very challenging. And if you assess the market and say, well, it's a different technology, but I have a company, Bechtel in this case, can actually build the thing, and I've got more confidence in them executing it, that would probably be the way you will go. So it's the selection of it is really led by the constructability more than thinking that one technology is better than the other. They're just different. But getting these things built is a real challenge, especially if you're in a remote area. That's why the US Gulf Coast is so competitive, because it's a very controlled environment. So this is the sort of technology that's been used in the actually in all the plants that have pretty much ever been built, which is interesting. So you can see that let's see this one. Yeah, so yeah, this is there it is. So this is the cockpit that's on the light blue, and then the others are variations of the first one. So look at what one of these plants looks like. I'm using the Gorgon project in Australia because it's sort of got everything you could ever want in an LNG project. And this is a top-down view of it, and you have gas coming in at the top, and it goes into a big pre-treatment area on the top left-hand side, and then into including 3 acid gas removals. So this is where it's got quite a lot of carbon dioxide. So it takes out the carbon dioxide here and sends it off to re-injection. So one of those CCS projects I mentioned at the end of the session we had this morning, where it's re-injected under the island. It then goes into 3 very large liquefaction trains here and goes down into these LNG storage tanks. And they're not very big. The LNG storage, well, they're big, but they're not, the capacity of them isn't that large. It's about 3 days worth. So of course, if you don't want to run them from top to bottom, that isn't really 3 days worth. It's more like 2 1/4. So you have to have a tanker there pretty much all the time, because if you don't, and you start to get near the top of that, you have to stop production. So it's a constant juggling act to try and make sure you don't hit what's called tank tops. And the reason for that is because it's so expensive to build those tanks. And you've also got things like condensate storage and an export jetty. But the reported cost of this is what I found publicly, $54 billion to build that one project. So it's the biggest single resource project in Australian history. And it's cost a lot more than it should have done for a variety of reasons, which I probably won't go into. Let's just look at it from another perspective. There you go. So that's looking at the out here. There's the jetty out there. I think it's a 2.5 kilometer jetty out into deep water. You need sort of something around 13 meters to be able to get the tankers in. So there's dredging going in. One of the issues with these is if there's something happens in the plant, you've got to do something with the gas that's coming in from offshore. All the fields are subsea, about 70 kilometers offshore. So what do you do with the gas? Well, you've got to burn it somehow. So that's what these sort of barbecue type arrangements are. And these are vehicles. So these are what are called the ground flares. So if the plant trips and you have to flare all the gas, if they go into these massive sort of barbecue grill type things, everything in this plant is on a massive scale. And in fact, the quality of the gas you have is really quite important because, there you go. Because this part of what I've tried to put in that yellow oval shape that's before you even start trying to liquefy the gas. This is all pre-treatment. So it's taking the CO2 out, taking the liquids out, generating the power, dehydration, taking the water out, before you get into these bits that are liquefaction. So, and it's one of the reasons this plant is so expensive, is the quality of the gas that you have. The cost of that treatment is very expensive. And you can see the loading arrangement at the top. You've got two tankers. You can't load two at the same time, but you can berth two. I mentioned floating LNG production when I talked about Mozambique. And if I go back now, maybe a bit over 10 years, maybe 10 to 15 years, floating LNG was going to change the industry. That was the rhetoric out there. It was going to allow smaller remote gas fields to be developed by these floating LNG vessels that would go and deplete a small field and then move and so on. And that was going to open up access to a lot more in the way of reserves. And it kind of hasn't worked out like that, is the way I described it. And one of the reasons for that is that there have been a number of units built, as you can see here. In fact, almost each one of these is one unit that's been built. But they're actually relatively small. They're 1, 2, 3 million tons, whereas that previous plant that I showed you, the Gorgon plant, is 15.6. So you need an awful lot of these things to even come close to a conventional plant. And they've probably been built overcomplicated, is the way I describe it. If you look at that one on the left, that's the Shell one that's in North Australia, and it's very, very complex. You can see the size of it on that. That's the largest vessel that's ever been constructed anywhere of any type. It might be the largest moving object that's ever been constructed. A lot of your operability issues when you put that much stuff on top of a ship. And while it sounds good to sort of move these vessels around into different fields, what tends to happen is each field is sort of different, so it needs different types of equipment. It's got more carbon dioxide or less, or more liquids or less. So I think the early ones were not that successful. There are efforts made to try and standardize and move forward. So I think there'll always be a place for them, but I think it's more of a niche technology rather than something that's going to change the industry. As you keep going, you get to the LNG terminal itself, and there are two ways to do this. And this is the conventional way: is you just have something on shore and you build similar tanks to the ones you had on the other end, and you bring the ship in and you run it through some heat exchangers and send out regasified LNG into the system or into the power plant. And the issue with this is it takes quite a long time to do. You need to permit everything, and it's more expensive than the alternative, which is a floating solution, which is similar to the one down at the first gen has down at Batangas. So there are some good things though. It's more robust. If, for instance, you have typhoons coming through, as you do here, the other issue with floating arrangements is they have to go about every 5 years or so. They need to go and get recertified. So they have to go and get inspected. Whereas these things don't really have similar issues. So they're easier to expand and so on. So it's a cost versus schedule and operability trade-off. So what very often happens is that initially you will have a floating solution to get going quickly, and then you'll be planning on building one of these later. The tanks, I won't dwell on the tanks, but they're just very expensive to build. And one of the this is something called single containment, which means it's just got a single wall. But I really want to look at that, the bottom right photograph. It's like being in a cathedral when you go in one of these tanks. because it's this stainless steel sort of, it's called a membrane that is designed to expand and contract with the heat as it has to go down to -162. And they're just enormous tanks. You're all covered with this membrane. So you can see why it's so expensive. And of course, behind that, you've got layers of insulation before you get out into the tank walls. So the projects will tend to build the minimum they think they can get away with to try and minimize the cost. But the trade-off for that is you lose flexibility. That's just a different way of doing it. It's double containment, so it's got two walls. Let's talk about the floating FSRU, floating storage and regasification unit. So this is the type of arrangement you have down at Batangas with First Gen. And this has really grown very rapidly, this approach to bringing LNG in. It's quick to do. Generally, you take an old tanker. Generally, it's one that looks like that, not like that. The ones with the domes on them are generally the older ones, and they very often get converted. So you take an old one, or you can build a new one. So there are some that are doing that, and they're often deployed to be that stopgap solution. So, for instance, Germany was doing that when it needed gas because of the Ukraine situation, with bringing in FSRUs. One of the problems with it, of course, is you bring in a full LNG tanker, which will be newer and therefore bigger, and you can't unload it all into the FSRU. So you've got a problem with only taking partial cargoes, that sort of thing. In the event of a typhoon, it has to drive off somewhere and get away from the jetty, usually, which of course means that you're then not producing gas, potentially when you need it most. So you have to take that into account. And as I said, you need periodic inspections. And they're generally cheaper. They get you going. So these are some pictures of this one, FSRU, floating storage unit. So it doesn't have the regasification equipment on it. It'll just store and send it on shore where it'll be regasified. That's an FSRU, the one on the right. So you can see up here is the regassing. So this is what's happening at Batangas. And of course, there was the existing series of power stations that were using gas in the area onshore. And one of the questions is, well, do you put an onshore LNG terminal here? Or do you bring in, this is the FSRU here? And I think the answer is, well, you do this first and then potentially do that later on. Total, estimated 370 million of infrastructure to do that. That's without the vessel. So that's all the arms and the jetties and all those sorts of things. So even though it's cheaper, it's not that cheap. And in this particular case, it's a 2009 tanker, so actually quite a new tanker. It's got a reasonable amount of storage on it. And the difficulty you have, another difficulty is how do you actually buy the gas for this? Because you have to make sure your tanker arrives just when you're as low as you could possibly go without running out. And then you've got to fill it up, back up again as much as you possibly can. And orchestrating all that while you've got an not unstable, but variable demand on the other end is one of the challenges of operating these things. You just don't have a lot of flexibility. But this one, I understand, has been quite successful. I think they've bought 5 cargoes in so far. So this is the growth of those types of units, FSRUs. They're up to currently about 140 or so of them. So they've been really successful compared to floating LNG production. These have been very, very successful solutions on the regas side. So that's it on technology. I'm happy to answer any questions at that point. And then we'll talk about shipping.
Thank you very much, Mr. Theobald, for the very informative presentation. So, do we have any questions regarding the LNG technology?
Mr. Neil, I wanted to ask, what is an LNG trade?
Sorry?
What is an LNG trade?
LNG what?
Trade.
Oh, train. They're just called trains. It's the liquefaction. So it's one of these. That's it there. So that's the bit that takes the gas and liquefies it. So it has all of that equipment in it. Compressors, heat exchangers, and so on, that takes the gas down from ambient temperature down to -162. Yeah, so that's it. That's it. It's those. So you put the gas in that end, and it comes out as liquid that end.
I think this is industry term with using trade, meaning that 3, 1, 2, 3, 3, 1, 2, 3. So we're three. We always have a 3 trades. So we're 3, 1, 3, 2. So we say trade, meaning the pipeline as well, the 2.6 gigawatt times 2. So the one unit and 3. So we in the industry term, we use the word of trade. There's an
Yeah. I didn't know whether it was trains either to start when the start. Sorry.
Have you in the second question? What measures have you installed? What response measures have you installed on our floating structure in Batangas in the event that your safety measures fail?
I actually don't know, so I've not been involved in that project. But generally these things are there are various international standards that are used to cover things like if there was any product release or anything like that. In terms of what they've actually done at Batangas, I'm not sure.
I'm not sure there's such a thing as international standards as of yet. Actually, there are not enough states who have signed up to any convention and HMS.
The Philippines hasn't.
Oh.
No, well, it must be under the Philippines standard in that case.
Oh, this is the first time you're dealing with this type of thing. Actually.
Yeah. Well, they must have used something. Sorry, I can't be more clear. I'm not involved in the Batangas FSRU, so I don't know exactly how they've done it.
Is there anyone in the room who? No? What response measures have been installed on our Batangas floating storage facility in the event that the safety measures fail? Because for those of you who have been watching the news lately, you must be aware that the Coast Guard is now responding to an oil spill in the northern part of the country. So our mindset right now is somewhat in the disaster scenario.
Right.
It's not something to take lightly, so. It's not something to take lightly.
Mm.
So I wonder, we're discussing about this project, but not enough attention is given to this concern.
Well, I'm not sure you'd say it's not enough attention. It's maybe you don't have the right people in the room.
Okay, so not enough attention because those people should have been included in this room. Otherwise, why would Coast Guard be included in this room, sir? Coast Guard is not so much concerned with the economics of things. We are concerned with the safety, security, environmental protection.
We're here to share the general energy industry information. And for this specific other videos, other just like this FSR and how they are operating, what kind of measures, safety measures they are following. Maybe operator charter or that your FSR should be following some kind of safety measure. We are not involved in this, so we just don't. But I think. I know FSR is being operated by VW is a supporter, and charter should be watching and looking at. So these people are operating just facility, so they should have some kind of narrative. That's what my stage.
Okay, so now that we have gotten to know each other, then maybe we can you can point us to the right people to discuss this concept. Thank you.
Thank you, ma'am, for that question. We are in a GPDP 3 seminar on global LNG supply, demand, and pricing. So we are sharing information here, but we will take note of that question and we will email you our experts' answers. Thank you. Do we have any more questions? All right, so I think there's no more questions in the virtual space. We can move on to the